Let us talk about the integration of logarithmic and exponential functions. Now, there are three main formulas for this. The first one would be the integral of e to the power of x of dx would be equal to simply e to the power of x plus c. It is not affected by integral. The second one would be the integral of a, which represents a constant or a number, to the power of x of dx would be equal to a to the power of x over the natural log of a plus c. The third formula for this would be the integral of dx over x would be equal to the natural log of absolute value of x plus c. Let us start with some practice problem. The first one would be the integral of 2e to the power of x of dx. So, first thing you're going to do here is to put any constant or a number outside the integral. So, you can see here, 2 here is a number or a constant. So, you have to put this outside the integral. So, this would be 2 integral of e to the power of x of dx. And now, you can see here, the integral of e to the power of x corresponds to this. And so, the answer here would be e to the power of x plus c. So, this would be 2 multiplied by the integral of this, which is this one, e to the power of x plus c. And so, your final answer would be 2e to the power of x plus c. Next up would be the integral of 5 to the power of x dx. So, this corresponds to the second formula, which is this, a to the power of x, wherein a here is a number or a constant, such as 5. And so, the answer for this would be a to the power of x, which is 5 here represents a, so this would be 5 raised to the power of x over the natural log of a, which is ln of a here is equal to 5 plus c. I will be showing at the end of the video how this was derivated into this. For this one, the integral of 9 over x dx. So, as usual, we have to put the constant or the number outside the integral. So, 9 here would have to move outside the integral. So, this would be 9, the integral of 1 over x dx. And so, if you multiply 1 by dx, you would have 9 integral of dx over x. And so, you can see here now, it looks like the third formula. So, this would be 9 multiplied by the integral of this, which is this ln, or the natural log of absolute value of x, which corresponds to this, plus c. And so, your final answer would be 9 natural log of absolute value of x plus the constant of integration. Let us try this example, the integral of 2 to the power of x plus 3 of dx. So, you can see here now that it corresponds to the second formula. But as you can see here, it only has a singular variable raised to it. As we have here, it is not singular. So what we have to do here is to substitute this into a singular variable. Let's say u substitution. Let us use that. So let u here be this value, x plus 3. And so when using a substitution method, take the derivative. So this would be derivative of u equal to the derivative of x is 1, and the derivative of 3, which is a constant, is always 0, and multiply this by dx. And so we can see here that dx is simply du over 1, or simply du. And so now that you have your values here, you can substitute it into this integral. So this would be the integral of 2. Know that x plus 3 is also equal to u. So this would be 2 to the power of u multiplied by dx substitute it into its equal, which is du. 2 to the power of u of du. You can see here now, it may have a different variable, but the concept is the same anyway. So you can put this as 2 here is a representation. So this would be 2 to the power of u over ln of a, which is 2 plus c. And so for your final answer, you must put u back into its original form, which is x plus 3. And so your final answer would be 2 to the power of x plus 3 over the natural log of 2 plus c. So the integral of e to the power of x minus 1 over 7 of x of dx. So whenever you encounter 2 or more in here, it is best to split this into its part. So this would be first part and this would be the second part. So this would be the integral of e to the power of x of dx minus the integral of 1 over 7 of x of dx. And so we can focus on this first one. You can see here that the integral of e to the power of x dx is equal to e to the power of x plus c. But we will not put plus c first because we have to solve this other part of integral. So focusing on here, let me just rewrite this. This would be negative integral of 1 over 7 of x dx. And so whenever encountering an integral, you must put the constant outside. You can see here, 7 here is a constant. So you can put it outside the integral. So this would be negative 1 over 7, since 7 here is in the denominator, multiplied by the integral of 1 over x dx. And so multiplying 1 by dx, this would be dx over x. And now you can use this formula wherein this would be the answer. So this would be negative 1 over 7 multiplied by the integral of dx over x, which is ln of absolute value of x plus c now. And so combining that with this would be negative 1 over 7 plus the rest. This would be ln x, plus c. And so this is your final answer. The integral of 5x cubed minus 3x squared plus x, all divided by x squared of dx. So you know that they have all the same denominator, and so you can split this integral into 1, 2, and 3 parts. So this would be the first part, which is the integral of 5x cubed over x squared minus the integral of 3x squared over x squared. This should be all multiplied by the x plus the integral of x over x squared of dx. And so simplify this first. You can see here that x squared and x cubed will divide, and so this would be left with x. X squared here will cancel, x here will cancel, and you are left with x here. And so this would be the integral of 5x dx minus the integral of simply 3 dx plus the integral of 1 over x of dx. Now that we have this, put the constant outside the integral. You can multiply the x by 1 here now. Now we can simply integrate this one by one. For this first part, know that the integral of x by the power rule would be equal to x squared over 2 minus 3 multiplied by the integral of dx is simply x plus the integral of dx over x, which is this. So this would be natural log of absolute value of x plus c. And so your final answer would be 5x squared over 2 minus 3x plus natural log of x, natural log of absolute value of x plus c. For the next one, the integral of 7e to the power of x minus 9 over x plus 5 over 3 multiplied by x to the power of 8 of dx. So as usual, split the integral into 1, 2, 3 parts. Now that we have that, we must put all the constants outside the integral. So this would be 7 integral of e to the power of 8 of dx minus 9 integral of dx over x plus 5/3 integral of x to the power of 8 of dx. And so we can integrate this one by one. So 7 multiplied by the integral of e to the power of x is simply e to the power of x minus 9 multiplied by the integral of dx over x, which is equal to ln to the of the absolute value of x plus 5/3 multiplied by the integral of x to the power of 8. This is power rule, which is x to the power of 9 over 9 plus c. And so simplifying all of this, your final answer would be 7e to the power of x minus 9 natural log of absolute value of x plus 5x to the power of 9 over 3 multiplied by 9 would be 27 plus c. The integral of x cubed minus 3 to the power of x plus e to the power of x of dx. So once again, split this first in order to simplify it. And next up would be to put all constants outside the integral. There are no constants here. And though 3 here is a constant, but it is raised by x, so you cannot put it outside. And there is no constant in here, so you are all good. And now, take the integral of each. The integral of x cubed would be x to the power of 4 over 4 minus the integral of 3 to the power of x, which is the second formula, would be equal to 3 to the power of x over the natural log of 3 plus the integral of e to the power of x, which is this. And so this is your final answer. So let us try this. The integral of x multiplied by e to the power of 3x squared of dx. So whenever you encounter a problem like this, the best solution here is to simplify it first or use a u substitution. Let u here be the most complicated one, or the position. So this would be the most complicated position. So let u here be 3x squared. And so take the derivative. The derivative of 3x squared would be 6x dx. And so taking dx alone, transpose 6x to the other side, which would be du over 6 of x. And so this would be the integral of x multiplied by e raised to the power of 3x squared, which is u, and multiply it by dx, which is du over 6x. And so you can actually see here that it will be simplified because x here and x will cancel. And so you are left with here is 6. And so you can put this outside the integral, which makes this 1 over 6 integral of e to the power of u of du. And so e to the power of u of du is basically the same as this, just a different variable. So this would be 1 over 6 integral of the integral of e to the power of u is e to the power of u plus c. And so your final answer would be 1 over 6 e to the power of u here is 3x squared plus c, or e to the power of 3x squared over 6 plus c. For the last problem, the integral of dx over x multiplied by ln of x. So once again, whenever you encounter a problem like this, the best use of this would be to use u substitution. So let us substitute u as ln of x. Know that x is one part and ln of x is also one part. So u here be ln of x. And so the derivative of ln of x would be x prime, or the derivative of x, which is 1 over x multiplied by dx. And so taking dx alone, this would be equal to x multiplied by du, because it will be like that. And so this would be the integral of dx here is equal to x du over x multiplied by ln of x, which is u. And you can actually see here that x will cancel, leaving you with the integral of du over u, which corresponds to this formula. And so your answer here would be the natural log of absolute value of u plus c. And so putting u back into its original form, which is ln of x, your final answer would be natural log of absolute value of ln of x plus c. And so let us start on how this became like this. And so this would be the integral of a to the power of x of dx. So you must be aware of the identity of ax is equal to e to the power of x multiplied by ln of a. So rewriting this would be the integral of e to the power of x ln of a of dx. And so the best move here would be to use u substitution. So let u here be this entire section, which is x ln of a. So when taking its derivative, but first we must know this, ln of a is basically just a constant, because when you input ln of 2 or something, it will give you a constant. So this is basically like x multiplied by 2. And so the derivative of 2x would be equal to 2. And so by that logic, the derivative of x ln a, since this is a constant, this is a variable, the derivative of this would be simply ln of a multiplied by dx. And so dx right here would be equal to du over ln of a. So rewriting that, this would be the integral of e to the power of x ln a, which is u, multiplied by dx, which is du over ln of a. And so this would be the integral of e to the power of u of du over ln of a. So as we had told earlier, ln of a is a constant, so you can put this outside the integral. So this would be 1 over ln of a integral of e to the power of u of du. And so as you are aware, the integral of e to the power of u corresponds to this. And so the answer here would be 1 over ln of a multiplied by e to the power of u plus c. So multiplying this, it would be e to the power of u over ln of a plus c. And now we can put u back into its original form, which is x ln of a. X ln of a over ln of a plus c. And so you can see here, e to the power of x ln of a is the same as this, which is the same as a to the power of x. So you can rewrite this as a to the power of x ln of a plus c, which is this answer.